This instruction is on finding Poissons ratio for aluminum. When a material is put in tension, it gets longer in the axial direction and shorter in the lateral direction. The ratio of those two strains, lateral to axial, is Poissons ratio. There's a negative sign here to make sure that Poissons ratio is the absolute value, always positive. The way we're going to do this in the lab is with a beam and bending. This is an aluminum beam and bending. And we're going to put a strain gauge on top aligned along the axis of the beam. The top of the beam will be in tension, and that strain gauge will be measuring the axial strain. So that gauge will read positive. On the bottom of the beam, there's a strain gauge aligned across the beam to measure the lateral strain. In the bottom of the beam, because of bending, is in compression. It's measuring a lateral strain, which is negative, so that it actually will read positive. The way you're going to do this, the equipment you're going to use, and the way you're going to do this is, since you have two strain gauges to read on the same strain indicator, you have something called a switch and balance unit. It allows you to switch channels to read the two different strain gauges. The axial is on channel 5 and the lateral is on channel 6. So what you'll do is put it on channel 5. This knob will allow you to balance channel 5, hopefully to 0, and then switch it to channel 6. And I think that's the knob that will allow you to balance it, hopefully to 0. And then what you'll do is push down with your finger or thumb and watch channel 6 reading, and make this difference 500. Make this close to 500, that difference. And when you get close to that number, use the micrometer to fine-tune it to get as close as you can to have a difference of 500 microstrain. And then read the final reading and get this difference here that will give you the axial and lateral strains. Now, there's one complication with that, and that is that, notice this gauge on the bottom of the beam is measuring, is lined up so that it's measuring across the bottom of the beam the lateral strain, which we know is less than the axial strain. And in an opposite direction, so this would be in tension, and in the opposite direction in compression is the axial strain. This is on the bottom of the beam. Now, strain gauges are made, as you saw in the video for strain gauges, they're made by looping wires. They keep looping these wires, and the reason they do that is so that it will increase the sensitivity to change the resistance as the length changes. Well, as it happens, the loops that go around the end of this beam, of these loops of wires, also experience change in resistance due to this compression, and that contaminates the reading. This is called transverse sensitivity in a strain gauge. Now, the way you correct for that, we have a chart that will allow you to correct for that. So what you need to do, now notice it's asking you for the strain gauge transverse and axial. The transverse in our case is going to be this direction, and the axial in the strain gauge is going to be this direction. And we know that for aluminum, Poissons ratio is about 0.3. So the larger value in this case is going to be about 3 times the smaller value. So that means, and they're negative of each other. In other words, the ratio of transverse to axial from the gauge perspective is about -3. So you will use this. Our strain gauge has a case of T, and you find this on the strain gauge data package. of 1%. So you will read off about, this is the correction factor that you're going to need when in the data, in calculating your data.